Welcome to Mitchell Maths. In this video we're going to have a look at trigonometric ratio. Now with trigonometric ratio you have some exact values which you need to learn, which are given in the table. And there's two ways you can learn some of the values. You can either learn the triangles and work the values out from what we call as special triangles, or you can learn all the values off by heart. The values for 0 and 90, you'll notice I've shaded those rows in a different colour. And the reason I've shaded those rows differently is because those two values need to be worked off from the trigonometric graphs. If you're confused by the graphs, I do have another video on trigonometric graphs which you can watch to see how we'd work out these values. But the ones we're going to look at mainly today is going to be 30, 45 and 60, which you can work out from the special triangles, or you can memorise the values off by heart. So what I'm going to do is I'm going to show you how to draw the two triangles you need to. So we're going to start off with 45 degrees. So I've got 45 and 45. This forms an isosceles triangle. And it's going to be, there's two sides we're going to label 1 and 1. And to work out the hypotenuse, what you do is you do the square root of 1 squared plus 1 squared. Well, the square root of 1 squared plus 1 squared is just root 2. So that's our hypotenuse. In our other triangle, we're going to use the values of 60 degrees and 30 degrees. So that'll be our 60, we'll have our 30 degrees here. It's always on, the 30 degrees is always on the longer side. And the two values are 1 and root 3. And the hypotenuse is just 1 squared and root 3 squared. Well, root 3 squared will be 3. So it'll be 1 plus 3, which will be the square root of 4. The square root of 4 is a value of 2. So the hypotenuse in this triangle is 2. And if we can draw these two triangles, we can work out any of the values, 30, 45 and 60 degrees, which we want. So let's take, for example, sine 45. Well, sine 45, if we look at we can use either of the angles. The opposite is going to be 1. And the hypotenuse is going to be root 2, because we know that sine theta, sine angle equals opposite over hypotenuse. So sine 45 would be 1 over square root of 2. And we could look at our table and you can see that sine 45 is 1 over root 2. Let's say we wanted to work out cos 30. Well, we know that cos angle is cas, so it's adjacent over hypotenuse. If we go to cos 30, we can see that adjacent is root 3, so it would be root 3, and the hypotenuse is 2. So it would be the square root of 3 over 2. If we look at our triangle at cos 30, it is the square root of 3 over 2. So that's our value for cos 30. Now, sometimes in questions, you will get questions which just want you to state the exact values. They're usually worth 1 mark. So if you know the values, it's just an easy mark to pick up. Sine 30, we can either draw the triangle or we might have just memorised it. If I draw the triangle just for, it'd be 30, 60, it was 1, root 3 and 2, so that's just the triangle we drew on the last slide. And if I want to find out what sine 30 is, I need to do opposite over hypotenuse. So if I go from 30, I go opposite, it'll be 1, hypotenuse will be 2. So it will be 1 over 2, because we know that sine angle equals O over H. Next, we're going to look at cos 45. Well, cos angle is A over H. And we can draw the triangle for that, which is 45 degrees. Both non-right angles. And this will be 1 and square root of 2 like we drew on the other page. And if I look from either of the angles, the adjacent is 1 and the hypotenuse is root 2. So because it's adjacent over hypotenuse, it's going to be 1 over the square root of 2. And tan angle is equal to opposite over adjacent. So I can write tan 30 equals O over A. And if I have a look at this triangle here, well, I've got the opposite. If we look, the side opposite 30 degrees is 1. And the side adjacent to 30 degrees is root 3. So it'll be 1 over root 3. So the value of tan 30 is 1 divided by root 3. So those are easy marks to pick up if you know the triangles or you've learnt them off by heart. They will be on the non-calculator paper, otherwise you'll just be able to type them into your calculator to work out those values. Right, so this question wants us to write the following in the form A root B, where A and B are integers. So firstly, we're going to think about what sine 45 and cos 45 degrees equal. Well, they're both actually equal to 1 over root 2 because of the triangle. So I've got 5 times 1 over root 2 plus 3 over 1 over root 2. And if I multiply those values by 5 and 3, I'll get 5 over root 2 plus 3 over root 2. Well, the denominator is the same, so I can add the fractions, which will give me 8 over root 2. And the thing is, the question asked me to give it in the form of A square root B. And at the moment, the square root is on the bottom of the fraction. And in order to do that, I need to do something that, well, sometimes it's called rationalising a denominator. I need to get the root off the bottom onto the top of the fraction. And the way I'm going to do that is I'm going to times both the top and bottom by the square root of 2. So that will get me, on the top, it'll be 8 times root 2, which will be 8 root 2. On the bottom, the square root of 2 times the square root of 2 will be 2. So I've got 8 root 2 over 2, which is equal, 8 divided by 2 is 4. So my answer is 4 root 2. A is 4, B is 2. In this next question, it wants us to give it in the form of root k. And we've got 18 sine 60 minus 7 tan 60. And they're both special values. So it's, again, it'll be a non-calculator question. And sine 60 is opposite over hypotenuse, which is root 3 over 2. So we'll get 18 times root 3 over 2. And tan angle is opposite over adjacent. So tan 60 is going to be root 3 over 1, which is just square root of 3. So we've got minus 7 square root of 3. I've got 18 root 3 over 2 minus 7 root 3. Well, 18 over 2 is 9, so it's going to be 9 square root of 3. Take away 7 the square root of 3, which will give me 2 square root 3. However, you do need to be careful here because the question asks us to give it as root k, and we've got an answer of 2 root 3. So in order to write it as a single surd, what we need to do is we need to do the reverse of what we do when we simplify surds. So I'm going to put 2 back under a square root. So 2 squared would be 4. So it'll be like 4 root 3. And if we times those thirds together, we get root 12. So our answer is square root of 12, where k is equal to 12. And for our final question, we're going to have a look at what happens when we put this into a triangle. So below is a right angled triangle and it wants us to find the exact value of b. And I'm going to label a triangle like I would normally do, opposite, adjacent, hypotenuse. And for right amount of value, so cator. Well, I've got the hypotenuse and I want to find the adjacent. So the formula I'm going to need to use is I'm going to need to use cos. Cos angle equals adjacent over hypotenuse. Well, the angle is 60 degrees, so I'm going to write cos 60 equals, I need to find the adjacent, which is b. And that's over the hypotenuse, and the hypotenuse has a value of 8. And now I need to rearrange this formula to find out what b is. So I'm going to multiply both sides by 8. So I have 8 times cos 60. Well, cos 60 is going to be the adjacent, which is 1, over the hypotenuse, which is 2. Which means it's going to be a half. So it's 8 multiplied by a half. 8 times a half is 4. So your value for b is 4 centimetres. And that's the answer to that question. So sometimes you will get questions like that, where you have your exact values and you've either got like normal SOHCAHTOA, you could have sine or cosine rule with that. You could also have finding the area of a triangle where you need to use the formula half AB times sine C. Right, thank you for watching. Hope you found that helpful. If you liked the video and like to see more, please hit the subscribe button. For practice questions, visit www.mitchellmathsandscience.com. The link is in the description.